we're looking for the unknown angle. We call these inverse trigonometric functions. So a trigonometric function looks like this, for example, y equals sine x. Okay, x is the input, x is an angle, and the output is a ratio. But what if we're doing the inverse this time? What if we're given the ratio and we want to go and find the angle, which is kind of like what we're doing here? Well, this is how we go about it. To get the angle here, what do we have? We have, this question involves an angle, and we've got two sides. So for this angle, this is the opposite, this is the hypotenuse, and this is the adjacent. So we've got adjacent and hypotenuse. Soh-cah-toa, soh-cah, cos. So we're going to do cos. Cos theta is adjacent over hypotenuse, 6 over 17. And from this step, this is where we go in and find what theta is. And what theta is this. We say theta equals, I'm just going to write it, bear with me, cos, with a little minus 1, 6 over 17. And then you have to go onto your calculator and get what that is. The minus 1, it's not an exponent. It's just called, and we do that for inverse functions, remember? If you've got a function f of x, what's the inverse of that function? F minus 1x. One undoes the other. And remember, f of minus 1 of f of x gives what? Okay, the function and its inverse cancel each other out. They kill each other off just to leave x. So what we're actually doing here, if I was going to put in another step, cos theta equals 6 over 17, what I'm actually doing is I'm going to take cos minus 1 of both sides. Cos minus 1 of that, cos minus 1 of that. And what did I say happens? A function and its inverse cancel each other out, and you're just left with whatever this is. So in other words here, the cos and the inverse cos are going to cancel out, which gives us this equation here. So we go from here to here, okay? That's actually what's happening. We don't usually bother writing that. You just go from here, bang, to there. And now you take out your GDC and make sure you're in degree mode. You push the shift button, so you've got cosine there. You type second cosine, and you'll see just above the cosine in blue there, it says cos minus 1. That is your inverse function that you're looking for. And if you're in the correct mode in degrees, you should get theta equals 69.3 degrees. And for this question, we're rounding to the nearest tenth. So nearest tenth, of course, just means 1 decimal place. If you wanted this answer in radians, you want to have it in radian mode first, your GDC. Now we're just going to get some more GDC practice, just to make sure you're using your GDC correctly. Use it to evaluate these expressions. And we're going to get it in radians and degrees. So what I'd suggest is, do both of these questions with your calculator in radians mode first, write the answers, and then change modes to degree mode and do it all again. Okay, so you're going to get 2 answers for each one. Pause, go ahead and do it. Okay, and I'll reveal the answers in 3, 2, 1, 0. There we go. So we wanted the nearest hundredth for these, right? Which of course means 2 decimal places each. So inverse cos of 0.78, that's how you'd say that, by the way. Inverse cosine of 0.78. 0.68 in radians, or 38.74 in degrees, 2 decimal places each. And the inverse tan of 1.23, there you go. Hopefully you got that right. Okay, and moving on for the last example, let's put our GDC to the side. Can you do this without your GDC? So you've got these exact values again. And we're going to get this in radians and degrees. So sine inverse sine of root 2 over 2, what's that? Think of it this way. We're looking for some angle theta, that is. Some angle theta says that is equal to inverse sine of root 2 over 2. Remember this step? What if I went backwards, went from here to here? That's the same as saying sine theta equals root 2 over 2. Sine what is root 2 over 2? Hopefully you remember that. Sine what is root 2 over 2? Sine 45 is root 2 over 2. Okay, so that's degrees, so it's the radians degrees. We'll do degrees first. And what's 45 degrees in radians? You know that. That is pi over 4. Okay, and another one. Inverse tan of root 3. So the question's saying tan what is root 3? So you've got to go back to your triangles. Tan what is root 3? The answer is tan 60 is root 3. Okay, and what's 60 degrees in radians? That is pi over 3. Okay, remember pi is 180, so 60 is going to be that divided by 3.